Alrighty, everybody. So before we start building out the actual wallet module that is holding your keys, I thought it would be a good idea to actually kind of explain what it is that these keys represent, because we call them keys, but your physical mental model of what these keys are is probably not correct, because we just call them keys kind of for what they're used for, but the actual implementation of them is a little bit more complicated. So here we have our private key, and this you'll see whenever we start building it out. This is going to be the structure of our private key. Is a private key consists of a public key and D. And D is a random number that in Go is going to be represented by a big int pointer. But this is really the same as the SHA-256 as far as how large it is 2 to the 256th power, which is a very, very large number, just in case you were wondering. But so this random number, huge, millions and millions and millions and billions and trillions, and our public key. And this public key is actually a data structure in and of itself. And so this public key data structure consists of an elliptic curve and an XY coordinate on this elliptic curve. And there's a function that we will call that is going to generate both a private key and a public key. And so you can kind of see it has to start at the bottom. We have to generate a public key that has an elliptic curve and an XY coordinate, and then a private key on top of that is going to use the public key and this D number. And so we can go over here and to see what an elliptic curve is. And so you can see an elliptic curve can take a couple of different shapes. This is the general formula for an elliptic curve, and it has some algebraic properties that are useful to us for things such as cryptography and other security use cases. And so you can see it has this curve where we have y going in either direction that is mirrored for infinity up and down on our y coordinate. And then we have this little circle here. And so this circle can actually be integrated into the curve. You can see plus 10, you can see plus 20, you can place 60, it doesn't really matter. Just note that there is the curve where it has the two lines going up and down and then meeting somewhere on this, kind of curve that gets generated. And so that's any point on here. So we have the elliptic curve. Any point on here will be an XY coordinate. And where D comes in is D is going to be a number, and this number is going to be the amount of times we kind of pick a point on this graph. So as you can imagine, with such a large number, this introduces quite a bit of randomness in addition to the randomness that is generated from the actual elliptic curve, because this is also randomly seeded whenever we call the function. So it could be any elliptic curve, and then on this elliptic curve, it can generate any XY coordinate, and then we're going to pick any XY coordinate D number of times. So, it could be like 7 billion or something like that, but that's not really necessary for this example. Say it was 3. We're going to generate 3 different points. So it'll be, let's say that's point 1, boom, point 2, boom, and then point 3. And whenever we get to 3, that's our last one. This is going to be our private key that has our public key that has the X and Y coordinates on this elliptic curve. And so let me pick an easier number to actually kind of read off here. We'll just say 4. So we have 2.62 and 4.05 would be the XY coordinates of our private key. And so that's kind of what we're going to be building out. I just wanted to show y'all that this is kind of the math that allows our keys to be secure. So we randomly generated that XY coordinate on the private key, and then we're going to do a bunch of things because our public key can be generated from any point on this graph. So that's how our private keys and our public keys are mathematically related to each other. And as you can imagine, that kind of comes with some security risks that we need to mitigate, because if we gave someone our public key, then they kind of know, not just based off of that, but they could use a couple other things to kind of determine if we had multiple public keys. they could kind of see what the actual graph is, and they could kind of start trying to get a more educated guess at what our private key is. So next, I'll show you in the actual code how it is that we're going to stop that from happening.